Dry corrosion. This is gaseous corrosion that happens basically inside the turbine of an aircraft. For things to happen dry at an appreciable rate, you really need high temperatures. The temperatures inside a jet turbine are 2500 degrees, 2000 to 2500 degrees gas temperature. Because of cooling on the metal's not quite that hot, but you're looking at very high temperatures. The combustion chamber inside a jet engine and the high temperature components are made from nickel. Once again, because the nickel metal forms that coherent oxide scale layer that just adheres to the surface. Nickel oxide adheres to the surface, and because it's stuck to the surface, it means no more oxygen. It's a barrier to oxygen, so it stops further oxidation from happening. Nickel is the high temperature metal. Everything in industry that is high temperature is usually made from nickel. Of course, gold doesn't react either. Gold tends to melt at 1500 degrees, but the affordable option is nickel. So not much more I can really say about dry corrosion. It's just high temperature reaction in the absence of water. So it's direct water, I will say. Oxygen can dissolve there and transmit over as an oxygen ion. It can dissolve and transmit. Dry corrosion, everything has to happen at the surface, at the interface, so it tends to be slower because of that. It tends to be slower because of that kinetics, and the reaction dynamics are slower because everything can only happen in one spot. It can't happen everywhere and then migrate ions to the reaction site.